Okay, today for 422, we're going to be making connections between systems and solutions and graphs. So the first problem says the hills are alive. The Alpine Music Club is going on its annual music trip. The members of the club are yodelers and they like to play the xylophone. This year they're taking the xylophones on a gondola to give a performance at the top of Mount Monch. The gondola conductor charges $2 for each yodeler and $1 for each xylophone. It costs $40 for the entire club, including xylophones, to ride the gondola. 2 yodelers can share a xylophone, so the number of yodelers on the gondola is twice the number of xylophones. How many yodelers and how many xylophones are on the gondola? So here's our test. Represent the problem with a system of equations, solve the system, and explain how the solution relates to the yodelers on the music trip, and represent this problem with a graph. Identify how the solution of the problem appears to be on the graph. Things to keep in mind. Discussion points. How can the given information be represented with equations? What is the solution to a 2-variable equation? How can this problem be represented on a graph? And how does the solution appear on the graph? Okay, so this is one of those that's a really big problem with lots of steps. And so the further guidance will actually walk you through step by step on how to get all of that information. So when we look at 443, it says start by focusing on one aspect of the problem, the cost to ride the gondola. The conductor charges $2 for each yodeler and $1 for each xylophone. It costs $40 for the entire club with instruments to ride the gondola. So write an equation with 2 variables that represents the information, and be sure to define your variables. So first, I define my variables, y equals yodeler and x equals xylophone. So if you look at the thing, we know that the total is $40, and we know that it costs $2 for each yodeler and $1 for each xylophone. And so 2 times the number of yodelers will tell you the total cost for the yodelers, and 1 times each xylophone tell you the total cost of the xylophone, and $40 is the total cost. Then it says find a combination of xylophones and yodelers that will make your equation from part A true. Is this the only possible combination? So I just picked something random. So if you put 15 yodelers in here, 15 times 2 is 30. 30 plus what gives you 40? 30 plus 10. So there would be 10 xylophones. Is that the only possible combination? Absolutely not. I just made that one up. So then on the back, it's going to have us list 5 more combinations of xylophones and yodelers. And then with your team, decide on a good way to organize and share your list. So I didn't decide on a good way. I just kind of picked random things and threw them there. And so you could decide, maybe you would want to use a T-chart or a table, something like that, to organize them. So all of these, remember, it's $2 for every yodeler and $1 for every xylophone. So 2 times 10 is 20, plus 20 is 40. 2 times 0 is 0, plus 40 is 40. 2 times 20 is 40, plus 0 is 40. 2 times 5 is 10, so 10 plus 30 is 40. 2 times 18 is 36, plus 4 is 40. So then John says, I think there should be 28 xylophones and 8 yodelers on the gondola. Is he correct? Use the equation that you've written to explain why or why not. So he's saying that there would be 8 yodelers, so 2 times 8 is 16. 1 times 28 is 28. 16 plus 28 is 44. No, he would be wrong because the total was only $40. Helga says, each correct combination we found is a solution to our equation. Is this true? Explain what it means for something to be a solution of a 2-variable equation. Yes, solutions are when you can substitute in the numbers for both variables and it makes a true statement. Now consider, so now we're on to 44. Now consider the other piece of information. The number of yodelers is twice the number of xylophones. So write the equation or mathematical sentence that expresses that piece of information. So the number of yodelers is 2 times the number of xylophones. So is equals, and then 2 times xylophone will give you your yodelers. So now list 4 different combinations Well, if there were 0 xylophones, there would be 0 yodelers. If there were 10 xylophones, there would be 20 yodelers, and so on and so forth. Stay tuned to the next video for the rest of this problem.